before we get going. So, welcome everybody. Today we have natural insulation options for low carbon construction with Eric Fenno from Small Planet Supply. I am Itzel Torres and I am calling from our Ventura County 3C Run office. And yeah, very, very happy to see everyone here. Next slide, Eric. Yeah, so before we get started, I know you all are very familiar with Zoom at this point, I'm sure, but just quick reminders to mute your mic if it's on, and if you have any questions, drop it in the chat box and we'll get to them. Eric's really good at answering questions throughout too, but we'll have some dedicated time at the end to answer some questions as well. Next slide. And just a little bit about 3C Ren if you're not familiar with who we are. We're a collaboration of 3 counties, so Santa Barbara, San Luis Obispo, and Ventura, coming together to implement energy efficient programs throughout the Central Coast. Next slide, please. And this is 6 programs that we offer under 3C Run. One of them two of them offering incentives, and then 2 of them offering training, and 2 other ones offering technical assistance. The one that is hosting this event today is our building performance training program, which offers a lot of different support and trainings for building industry professionals. And with that, I'll hand it over to Eric to get us started today. I think you're on mute. Okay.
There we go. Yeah, so I was the "this is being recorded" bar was over my audio controls. So hello everyone. Thank you for being here. This is a really fun presentation. Insulation's just a fun topic in general. And I actually get to see some of you now, which I didn't used to, so that's fun. Um, Insulation is a good way to reduce environmental impacts of your project. We use a lot of it. It's a big component of a structure. Um, so it's good for carbon, but it's also a good way to improve resilience and reduce contaminants in your living spaces. It's a good thing to target if those are some of your goals. I'm talking specifically about cork and wool insulation as examples in this presentation, but there are a lot of other materials out there that may work for your project, and requirements for every project are a little bit different. Everybody has, kind of they're in a slightly different place on that spectrum of, I want to do this, I have ecological concerns, I have health concerns. So I'm also going to be talking about some other resources that can help you sort of determine if a product is in line with what you're trying to get into your project. So I'm a pragmatist at heart. I do not like it when perfection becomes the death of good. Half of something is better than all or nothing. And not every project has the same requirements. They don't all have the same budget. So I wanted to look at some of those tools we can use to assess instead of just giving you a blanket prescription, as well as talking about those 2 examples of cork and wool. In the past, this would kind of be where I lay groundwork and smack talk code a little bit and conventional practices. But actually, codes are kind of starting to catch up with building science. As of the 21 energy code cycle, at least in some of the more attentive parts of the country, like California, we're getting pretty close to what I would call a practical ideal. Maybe not all the way out to maximum performance, but like pretty good, not bad. And for building codes, for me, that's high praise. We are still learning. A big part of that learning right now is on execution side. One of the issues you can run into with code prescriptions is that they're really based on the assumption of good install, good practices, and that doesn't always make it into the finished product. And then we also can run into sort of conflicting standards with code as well, where there's like a point system in Washington where I'm at. Sometimes you can get enough points to pass doing some things, and you can kind of skate by on other things that are integral to the success of the things you got points for. So just a reminder that insulation is a component of a system. I would still strongly encourage you to air seal appropriately, ventilate correctly, because a house is a system. And that's really how we need to think about it these days. Um, One thing that is new enough to bring up that you've probably run into with your code by now is that insulation is works best in kind of this combined system where we have this continuous rigid exterior insulation and then this bulk layer inside in your cavities. And we'll get into why that is in a little bit. But for now, I just want to establish that we have some different requirements for those two materials. There absolutely is something, material that's better at being exterior insulation than being cavity insulation and the other way around, right? Um, the topic of natural materials is, did I skip one? No. The topic of natural materials is always kind of a funny one because, oil is naturally occurring. You can just pull it out of the ground. Asbestos is naturally occurring, ozone. So when we talk about natural, we don't really mean stuff you can find in nature. And furthermore, nothing makes it to a job site without going through a factory or two. So processing is always a part of it. And like I said, I think everyone has some notions of what they'd like to see as far as what's going into that product and what the finished product is going to do once it's in situ. Um, so just maybe some things you could consider when you're assessing things for your project. Embodied carbon has been a really big topic within Passive House and other circles lately, last couple of years. It's getting to the point where just about everybody's heard it. But if you haven't, this is a more comprehensive way to assess total carbon output of a product from your raw material gathering to the installation to the end of your life, right? Disposing of it. And that information isn't always readily available, but there are a number of databases out there for embodied carbon and building materials. I'll show you some possibly easier ways to find that information a little bit later on. Um, Processing of material can be something people weigh in their natural versus non-natural calculus, right? I think the reasoning there for a lot of folks is the further away from an original form something gets, the more it becomes something else. Um, so there's kind of a visual side of it, but processing can also introduce contaminants or chemicals that people don't really want to be exposed to. It can be an indicator of potential health concerns. And the visual part of it is meaningful, right? Because we want our houses to be beautiful. We want to know that good stuff is going into them. If it looks like a terrible industrial chemical mess, that translates. In that vein, treatments for stuff like insulation, especially insulation, are usually to prevent mold growth or pest intrusion. That's something that people look out for. It's something I would recommend looking out for. Pesticides and fungicides, especially, can be pretty nasty. So it's a reasonable one to look at. And I will say that there's a certain amount of this treatment that is valuable, right? We don't want mice in the walls. We don't want mold. Those can cause their own health and durability issues. But what chemical is being used and sort of the volume of that chemical are important things to consider. So talking about some criteria we want to look at when we're selecting insulation, I am starting kind of basic here, but insulation is rated in R values. We're all familiar with that more or less. R value is a metric that does contain useful information, but you have to work a lot harder than you really would want to when you're just looking at materials. Heat transfer is complicated, and so you can't just say something really intuitive like this will keep your house at 70 degrees for an hour with no heat input. There's no way, it's all based on ambient conditions, what temperature is it outside, humidity. For our purposes, it's just a standard we can use to compare relative effectiveness in generalized conditions against other materials. And then your code office will tell you, what they want you to use. And if you're working on a standard like Passive House or similar, they will also have prescriptions for you. Um, And again, those code standards are getting pretty okay. There's still a little bit of work to do, but um, it's not a bad baseline anymore. So for a reference point, these are our values of just the stuff that we normally use. So fiberglass, roughly an R4. That varies on type, right? Blown in actually is a lot lower. Um, Cellulose is 3.5-ish to 4. Polyiso is a little bit higher. The one that can shock people sometimes is that still air is basically the same R value as, fiberglass, cellulose. And that's because that's where the R value for those materials come from. They are basically a matrix that traps air and holds it still. And the matrix itself is usually the thing that drops your R value in most cases just by being conductive. Fiberglass is kind of the standard I measure against for sort of determining effectiveness of materials. It's really common. It's what we use most of the time. It's pretty good at its job, and it is just miserable to deal with. I just spent some time in an attic with a lot of it, and I itched for days. So it's this thing that works really well. Everybody's familiar, but it has issues that nobody wants to deal with, and so it's a good reference point for like how do we do better than that. So cavity insulation is pretty well established at this point. We've been doing that for a long time. Exterior insulation is still new for a lot of folks, even though a lot of places have code requirements for it now. You do want to have both. So exterior insulation benefits from different properties than cavity insulation, and we talked about that a little bit earlier, but namely, we want our exterior insulation to be continuous. We want it to be a sort of this unbroken surface all the way around our building envelope, and we want it to be rigid because it's going to be on the outside. It needs to hold up to the elements a little bit. Usually you'll have cladding over it, but still exposure to like heat fluctuation and moisture is going to be a lot higher than if it was an interior material. With careful detailing, some exterior insulation materials actually can be your finished material, and we'll see that in a little bit. Um, a little counterintuitively, exterior insulation doesn't need to be all that thick. So you don't have to get massive bricks of a material. Usually a couple inches is fine. And you can see why on this chart here. So on the right, we've got our R values for standard materials. And then down at the bottom, you've got R values for normal framing materials. And so on the left here, we have a chart of heat flow through insulating materials. This is from Energy Vanguard, and if you're not familiar with them, you should go check them out. Allison Bales is amazing. But what we can see here is that we've got our normal R values here. So let's say we've got an R20 wall, but then we have like a 2x6, right? And there's nothing on the outside of the 2x6. So what we're getting where that 2x6 is the insulation value of that 2x6. It's creating a lower resistance path for heat to move through. That's why we would use exterior insulation. What we're finding is you can't really just look at a wall, add up, your ideal section and know how that wall is going to perform, right? You can't just go siding all insulation drywall. There's framing in there too. It's a complicated thing, sort of modeling a wall and determining performance, but kind of the best way to do it is the parallel path method, which is where you're looking at all the possible avenues, right? If you have cavities where you've got just insulation, but you also have spaces where you have just framing. So with that parallel path method, you're weighting based off of the area that materials occupy. And framing occupies a lot of space depending on, what your centers are. And it's, well, not really depending on it. It does occupy a lot of space in your walls. And so the exterior insulation deals with the bridging you get through those framing members, right? So a 2x6 would be what, an R7-ish, something like that. Um, and so if we look over here, we can see that is down into this curve here. But if we can add another maybe an R4 on top of that, we get a pretty meaningful drop down into the space. And if you have 2x4 walls, it's vital, right? If 2x4 wall, those framing members are going to be in R, what, 4, uh, which is going to put you way over here on the left on that second data point. So the exterior insulation is there to deal with these issues we get from bridging through framing members, and it also contributes to your overall R value. And of course, critically important these days, especially in California, also up here in the Pacific Northwest, is the fire rating. So there's a lot of good insulating materials out there. There's a lot of stuff that is good at insulating. The trick is finding ones that aren't also effectively just like tinder, given that fibers are really our go-to method for trapping air with a natural material. This is kind of harder than you might think. Fire ratings are based on flame spread, which is another one of those kind of wonky metrics. You just think lower is better. And so class A is our best. Usually they're self-extinguishing. They don't like to be on fire. Class B is in the middle, and that's most of your framing and your wood products, which seems kind of funny because you think of a campfire when you think of wood. But if you ever tried to start a campfire, right, maybe that'll make more sense. It can take some effort to get wood burning. Once it's on fire, it is on fire. It's then you have to put it out. Um, but it's kind of in the middle. And then Class C is about the worst you would want to put in a wall assembly. There are worse categories actually, but this is stuff that's not quite as hard to get smoldering or burning. This is stuff like plywood, fiberboard, some siding panels, and some woods, especially if they're really sappy. Um, but I put a hole in a piece of plywood with a firework once, and I set my lawn on fire, and my family still brings it up. So plywood is not fire resistant, so don't use it as a fire stuff on the 4th. Just pro tip. Class C. So on to our first example of a really nice natural product by my standards, cork insulation, right? And it is that kind of cork. It's about as natural as it gets, I think. It's the bark of a tree. It's an oak tree specifically. So cork is a material that has a long history of human use. They used to just use the bark, and actually I have a section of it in the showroom, where they would put it around their windows, stuff like that, in their homes. They used it for sandals. Um, and we've got a long history of human use with this material. The specific product that I'm talking about is 100% cork bark. So what I mean when I say it's as natural as it gets, there's no glue, there's no binder, there's no additional material in there. The adhesion actually happens when the cork gets heated and it gets pressed. The material will glue itself together. So it also doesn't harm the tree to harvest. It's carbon negative because the tree just keeps growing, and then they harvest it again when the bark grows back. It's so cool. Uh, Cork trees are actually protected by law in Portugal, which is where this specific product comes from. Uh, and that's how serious their relationship with cork bark is. You can't just go out and cut one down because you need firewood or you want lumber. The trees live for up to 250 years. You can harvest the bark about every 10 years without harming the tree. And it's the only species of tree that you can do that with. They're carefully marked, and they make sure that they only get harvested at that interval. It's all done by hand, and you use a special axe, and it's a generational thing for a lot of the workers. It takes a lot of skill to do without harming the tree. So for a lot of the folks that harvest it, it's been something that is passed down in their family. And so then once they harvest it, it gets straightened out, and most of it actually goes into wine corks. This is where wine corks come from. That's the high quality material that they get. The other products that, the other material rather gets turned into other products because it wouldn't be acceptable for use in wine. And that's what we get. We get the kind of the stuff that gets projected from the wine corks. Um, and so then they form it into bricks with steam and pressure, and suberin, a component of the bark, is what binds the cork together without adhesives. And that's how it goes from this beautiful forest into a beautiful building. Um, and the cork they harvest is mostly from Portugal. Some of it is from Spain. Uh, Again, they have this fascinating cultural connection to cork trees, stretches back hundreds or thousands of years. Um, and one of the interesting things about it, so I have a little bit of an agriculture background when I was a kid, and permaculture was something I was really interested in, which is where you basically create this biome with compatible plants and animals, and you create this self-sustaining resource. And so the Montado is very similar to a permaculture. It is lightly managed, so it's not like officially there, but basically what they have is a managed low density oak forest, and it's mostly these cork oaks that protect and shade livestock that graze underneath them. And they produce acorns that also feed the livestock. And most notably, if you've ever heard of like Jamon Iberico, that this is where they fatten those pigs up to create some really high quality ham. And they also provide a habitat for a huge variety of like wild game, fertile areas that they cultivate crops in, and the livestock fertilizes the trees and those crops, and then eat other things that might try to choke out the trees. Um, so it's just this really cool, beautiful system that they've got going on. Every time I read about cork, I get the warm and fuzzies. It's such a nice material. Um, there are a couple of grades that they produce, and the grade is density dependent. So the one we look at mostly for our insulation purposes is what they call standard grade. Um, Again, it's a little is this is a kind of a weird thing, but it's less dense than like the facade grade, which we'll get to in a second. Seems a little counterintuitive to have your insulation be less dense, but remember we're getting our R value from trapped air mostly, and so that lower density provides a little more trapped air, it provides a worse conductive path, and so it insulates just a little bit better. Cork has a lot of cool properties that make it perfect for exterior insulation. So when we look at it, we want something rigid and we want something waterproof so it can resist the elements, right? Even if it's behind that cladding, we don't need something with a crazy high R value, but we do need to get our required values in the space of a few inches. So, higher the better. We want to make sure it's not going to expand or contract, because that runs the risk of damaging our control layers, right? Our WRB behind the insulation, or the aesthetics, right? If your siding starts buckling, that's annoying. And ideally, it would not catch fire very easily. So what we get with cork is basically all of those things. It's R4 an inch in the standard grade, so comparable to fiberglass. Polyiso is a little bit higher, but it's good enough for the job. And one question I do get a lot is how does it deal with moisture? Because you look at it and it looks like OSB almost. It's a sheet good, and it looks like granular wood products. And OSB, of course, does not handle water well at all. Neither does plywood. And with cork, the answer is cork is naturally sort of hydrophobic. It doesn't absorb water. It doesn't expand when it gets wet. And actually, cork gets used for all kinds of things, not just homes. And I get a lot of the calls about it. So one week I got like 4 calls from different people about boats. They wanted to build boats with it. And so I ended up doing an experiment where I weighed a piece of cork and then I stuck it in a bucket full of water for 24 hours and I weighed it down so it just sank. And when I took it out the next day, it took on about 4% of weight after being completely submerged for 24 hours. It did not lose any structural integrity. It was still a piece of cork. It was exactly the same as it was when I put it in, and it dried out within like a day. So it handles moisture really, really well. It's dimensionally stable. It's not going to expand or contract. Um, does very, very well in wet environments, and we use it a lot here in the Pacific Northwest where it never stops raining. It's also surprisingly fire resistant. It's actually better than most wood products. It is still a Class B, partially because Class B is kind of broad, but it's on the higher end. It really does not like to burn. It'll smolder a little bit if you hold a torch to it. And actually, I've seen a video of them doing the testing on it where they have basically a big propane torch and they just stick a sheet of cork on top of it and see how long it takes to burn. And it never caught on fire during the video. It did start to smolder a little bit in there. So good for fires. And another fun kind of cork fact that I learned recently was the steaming and the pressing process removes the cellulose from it. And that was interesting to me because I get questions about termites a lot. And I had always figured it's not any more vulnerable than any other wood product, but actually it doesn't have the food source for them. That's what they eat is cellulose, and so they can't eat it. There's nothing for them there. It's just you know, it's a brick of wood that a termite can't eat. So all of those factors make cork a really good exterior insulation. It lasts a long time. Nominally, our expected life is 50 years, but we don't really know. It's probably a lot longer than that. Um, and then in our picture here, we've got a typical installation for the Northwest. We've got a little rain screen here. And then behind that, we have the standard grade. The standard grade you would, again, want to put a cladding material over. The facade grade is the one you don't have to put a cladding over. So, standard cork is really versatile. It's really useful. It does not hold up as a finished material. Because it's not as dense, it can be a little more susceptible to like wind, things like that. The facade grade is slightly denser and it's a lot more resistant to the elements at a very small penalty to R value. It's still comparable to some fiberglass products. It can be used as a cladding as well. So this can be your exterior insulation layer and your cladding. Um, so you do have to detail that. So you would want it in that case, of course, you don't want that air gap behind it, uh, which is such a stressful thing for me as a Pacific Northwest guy to say. But it does work out. We've done this up here and it was fine. Um, so you could do a few things with it. You could have, I would recommend a peel and stick, like a self-adhesive WRB behind it, or you could use in this drawing we have here on the slide, it's a liquid applied membrane. This is Cat 5 from Proseco, which is a roll-on WRB. The reason we recommend those is because they'll self-seal around fasteners. The facade panels are shiplapped, so they have an edge that's routed out, two edges that are routed out, and then you layer them. So that does help a little bit with the driving, but you can still get water back behind them. And so you definitely want to have your fasteners sealed really well, and you don't want to, have anything penetrating through your WRB that isn't sealed up. Um, We also have a decorative grade. This is not as much for insulation. It's really just for looks. They say don't put it outside. Although I do have people do that occasionally as like a little accent, maybe under a porch roof or something like that. But the big reason they say don't put it outside is just because all the little nooks and crannies in there can create spaces for critters to climb or live in. So I tend to recommend putting it inside. They're nice to look at. They're just cool decorative panels. They can help with noise. I don't have ratings for the decorative grade on sound attenuation. There is a specific, they call it vibratic. There is a sound rated panel that they do have test data available for. But we put this decorative stuff up in our office to deal with echoes, and it works out really well. So with all materials, you do get some trade-offs, and there are a few things that cork can't do, and just some stuff to know in general about it. Right. And so number one is birds like it sometimes, rarely. I don't get a lot of calls about it, but I do get a lot of questions about it. So I wanted to bring it up every once in a while, specifically with the facade. Like a woodpecker or other little birds can be drawn to it. It makes a hollow sound. and woodpeckers like that. So the woodpeckers usually will go away. They'll figure out there's nothing in the cork for them to eat. Bugs can't eat it. And they'll just go away eventually, or you can put up one of those little owl statues. There are also little birds called nuthatches. They want to live in it. So it does happen. It's just something to be aware of. It's not really that hard to deal with. You can plug up their hole and they'll go away. But it can be annoying. Cork is rot resistant, but it is still wood. And so not the thing to use for foundations or underground applications where there's no drying potential, because it can rot in those where if it has no ability to dry out, it can happen. Still got to use, I think foam's kind of the only thing you can do for subterranean. Could be wrong about that. It can be kind of brittle, right? So you want to avoid overdriving fasteners. You run into people talking about maybe not using nails with it. And I think that's why we don't have any specific prescription against it, but it would be pretty easy to overdrive with like a coil gun. Um, we hang it with a pin nailer in the office and it works out fine as far as, it doesn't fall over or anything. But just to be safe, I'd probably put it up with screws and not use nails for it. I would love to say, hey, go use this for everything, right? Why are you not? What are you doing? But going back and looking at the practicality thing, pork can be kind of expensive when you're doing more than a couple of inches of it. That's one of the reasons it really is best is that continuous exterior layer right there. It is pretty close. It's pretty reasonable. Once you start doing stuff like R20 cavity insulation with it, you can do it, but it is expensive. So I would probably steer you towards something like Havelock or the wool that is made to do that and is a little easier to work with and going to be a lot less expensive. Um, and then lead times with it can be a little bit long. It's something to anticipate. Pork is a natural product. It's harvested seasonally. And the majority of harvested cork goes to the wine industry, right? And of course, it comes from Portugal. So you can run into some timing issues if you don't plan ahead. And you wouldn't know to plan ahead if you weren't warned. So I'm telling you now, plan ahead. It can be like a 6-month lead time sometimes longer. If you're special ordering a non-standard size or something that the supplier is out of, can take a while. So now's a good time to kind of mention and go through one of my favorite things to happen over the past decade. And this is one of those tools I was talking to you about where we can assess a material. The Environmental Product Declaration. So these are documents that companies can put together, and it's using a standardized global framework to declare their product life cycle. And this is primarily with an eye towards carbon footprint, but it also gives you a decent idea of what goes into a material and what it's treated with, the manufacturing process. And so this can be a really good resource for both, those values-based assessments and for those practical kind of exposure and safety assessments. It's a fantastic tool for discerning if something is like natural enough for you, right? In line with what you want for your project, if it's actually sustainable, actually what it claims to be, because we do run into a lot of, oh, it's natural out there. So if they have one of these, then you can decide for yourself. In the interest, again, of not allowing perfection to be the death of good, right? Sometimes it's impractical to go with like the most bestest thing, and that's okay, right? Review these so you can get a sense of what's within your acceptable range. These are technically voluntary, but they're required for some certifications and they're required in some jurisdictions. So a lot of manufacturers are just making them. That helps them get selected on those projects that do need them. Before we take a look at one, I do want to mention this framework is administered and owned by a Swedish firm, which I mentioned for no reason in particular, and certainly not in reference to a potential rapid decline in the quality of domestically administered environmental reporting standards. It's just nice to know who's behind something sometimes. So with that, we will take a look at the EPD for cork insulation here. This is a pretty nice one. They don't all look this fancy. So we get our chain of ownership, right? Raw material to factory to transport. We get the testing organizations who actually sort of compiled everything, the scope of the EPD, some other testing criteria, and a quick summary of the results. So they do reference A1 to A3, and those are phases of manufacturing. We'll see that when we get to the flow chart here in a second. But this first page here is kind of totaling up A1 to A3, which is the manufacturing process. We get our raw material composition. So this is what I mean. You get an idea of what goes into a product, right? In this case, cork is just cork, so it's 100% cork. But if you had like a bitumen-based product or something that had additives like that, then you'd end up with like a mass percentage in the fossil materials category, so on. We get a life cycle assessment, and if you're ever feeling kind of hopeless about the state of the world and the toll that manufacturing takes on the world, this is a really nice thing to read. Cork's EPD is like the happy children's bedtime story of technical manufacturing disclosures. We already went over it, but like seriously, it's like we hire local artisans who've done this work for generations. They harvest it by hand in a happy little forest you've seen Bob Ross paint. Then they have some wine and we process it into grains, right? It's just a good one. You should read it. So then they talk about where does waste go, what does the end of life and the potential for recycling look like, and so on. They give you a full manufacturing process breakdown. So this is at A1 to 3. And you can also sort of cross-reference to where they declare energy inputs. And I like it because it does give you an indication, again, of that manufacturing process. So if you aren't super concerned about like the extraction of the raw materials, but you are concerned about stuff like local pollutants and where they're making it, these can be nice to consult. And then cutoff criteria shows you what they're not including in the EPD, and that is good to know. It is technically possible to conveniently exclude some things from these. You would think nobody would ever do something like that, but France did it so bad one time they had a whole revolution. It was a whole thing. It happens. Read your cutoff criteria always. All technical documents, if they have that, read it. And then just a summary of what's being emitted and the byproducts from the process. So this is one place you can find embodied carbon. If they have an EPD, it makes it pretty easy to figure out. There are those databases, but if they have one of these, you can kind of go in and you can break it down by life cycle, or you can sum all of these life cycles up, which is a little annoying because they always do this in scientific notation. You can see that these numbers are kind of wonky looking. They've got decimal and then the E, and that can make it a little annoying to convert if you're not super familiar with that. If you're not super familiar with that, the cheat code there is just whatever numbers after the E. If it's a positive number, that's how many places you move the decimal to the right. If it's a negative number, you do the same thing, but you go to the left and then you just fill in with zeros and that's your real number. But EPD is always nice to have. Some other documents you can kind of consult to determine if you want to use a product, right? Safety data sheets are really meant for installers, but they can still kind of tell you some stuff about what future occupants might be exposed to. Just about every country has these. They're good to look at even if you're only concerned about your installers. And then other resources that are valuable, but definitely on the stricter side of things. These are all administered by Living Future. They all kind of tie together. These guys do not play. It's hard to get on these lists. They have a lot of chemicals that are really common in building materials and even just everyday life. And they will automatically drop you from certification if you use them. They require really strict testing. And while they don't really weight naturalness into their standards, it does give you a sense of, again, what things have been treated with, what they're made of, and they do actually just give you a number for embodied carbon estimates. So on to our second example of a material is sheep's wool. And this is another one that I love to talk about. It's another one that kind of gives you the warm and fuzzies, and I'm not apologizing for that pun. Um, so I try to keep stuff brand agnostic for these because I do sell stuff, right? I do work for a business. But in the US, this is basically just one company. I already said it, I think, but it's Havelock, right? I'm talking about Havelock. Um, Wool is one of those materials where you look at it and you kind of go, yeah, obviously, right? When you think about it a little more deeply. Because we made clothes and we made blankets from wool for literal thousands of years. It's one of the oldest tools we have. We've used it for so long because it's a really good insulator. It manages moisture well. It's resistant to damage. It lives a long time, and you can get it off any sheep you can catch, and it'll just grow back. Right? It's free. It's like a cheat code. Um, as with many things, right, once we quantify the actual performance of this thing we've used forever, we can go, oh, hey, maybe those like Neolithic peoples were onto something with this. It's an R3.6 in bats. It's a little bit more in blown form, and so it passes the as good as fiberglass test. I get questions about odors and things sometimes, and we'll get into how they deal with that in a second. But the short answer is it doesn't have one. I mean, we have samples in the showroom that I forget about sometimes. So you can put your face in them and they don't smell like anything. Um, Wool doesn't trap moisture. It kind of it breathes, if you will. So it's really nice to have in wall cavities where you really don't want to have a lot of trap moisture. You want to have those be able to dry out, usually to the inside, so that you're not getting this big buildup of moisture in your wall cavity. And then they're also Class A fire rated. So this is self-extinguishing. We don't have fire concerns about it. Uh, it's got so many cool properties. Um, we'll get to that binding formaldehyde thing in a bit. That's wild. I'll show you that in a second. So Havelock gets their wool from New Zealand, which is known worldwide for making Lord of the Rings and having lots of sheeps. And so here we see a lot of sheep hanging out on the Lord of the Rings set. Havelock buys wool specifically from meat production sheep, and they do that to reduce some of their sheep husbandry impacts, right? Sheep farming and livestock in general can be a little intensive. So it's a little depressing to know that they're meat sheep, but it's a reasonable policy to have for a large purchaser of wool who isn't really concerned about making clothes out of it. And then maybe my favorite quality of any sustainable material when I can find it, um, wool is not horrifically expensive. Because a lot of the stuff you find out there that's really nice, happy, fuzzy unicorn stuff is really expensive. Wool is not the cheapest option out there, but it's fairly in line with like the brand name pink fiberglass stuff it's close, right? It's not that much more. It's totally doable, and for the benefits, I would say it's really worth it. I would pay more not to have to deal with fiberglass, right? And if I get benefits on top of that, awesome. Wool's life cycle is pretty straightforward. They harvest it in New Zealand, they just get it off the sheep, and then they wash it. And washing it, they call it scouring it. So it's a special process, but that's what deals with the odor. There's like some oil in the wool that they have to get out of it. Um, and so washing it is what takes care of that odor and then maybe that concern if you have it. Um, then they transport it to Havelock's facility, which is US based, and they treat it with boric acid. And so, a note on that, since we've been talking a little bit about chemicals and exposure. So, boric acid can have some health implications, right? It's primarily reproductive. Um, in these quantities, it's really more a matter of like, don't eat your insulation. Wash your hands after you handle it, and you'll be fine. It's important that we have it as well, um, especially since it's nice and relatively low impact. Because one thing you can run into with wool is bugs and rodents, and that's why they treat it. The boric acid deters them, and it works really well. It's also a fire retardant, which we don't really need, but it does help out. And then once it's treated, it gets processed through machines into either blown in insulation or into bats. And then they bundle it up and they send it out. The bats are probably my favorite format of the wool. they are just a drop-in replacement for fiberglass bats. You put them in the same way. They're pre-cut on standard framing centers. You just push them into a stud bay, and the framing holds them in place as long as you're using the right one. You can use staples for this, but I have never run into these not working, just being friction fit. The I would choose these because I'm lazy and I don't want to do all the netting for blown in. It's not that big a deal, but um, it's my personal preference. And the bats are available in an R15 and an R22. So you can hit your insulation requirement. I think California is, are you guys in R20 now? You can hit your insulation requirements. The 15s are made for a 2x4 wall, and the 22 is made for a 2x6 wall. So they're cut at 3.5 or 5.5. And then, of course, it's the wool. You can put it on without any gloves. You don't need PPE. It's not going to make you itchy. It's not going to mess your lungs up. Just, make sure you wash your hands after you handle it. Otherwise, you're good to go. And then they have a blown-in wool that has a little bit higher R value. It is a great option for attics and rafters. And the R value thing is a little wonky because blown-in insulation is complicated, but that's roughly what it works out to. And it's really easy for installers to pick up and roll with. Again, just like the bats, because it works the same way as what they're used to. And I mention that because we can run into stumbling points with new to market stuff, right? Wool isn't exactly new, but you can run into hesitancy if a product is too unfamiliar. And so this and the bats are just like any other insulation. People are used to it. It does have a slightly different blower. I believe you rent those from Havelock. But otherwise, you put up some netting, you blow it in, you fill your cavity, you make sure your density is good, you're done. Will sort of naturally resist sagging over time, which you can run into issues with in fiberglass, in cellulose, where they'll slump down and they'll lose R value over time. The bats, that's less of an issue, but the blown in, you can be really susceptible to that. And the wool is really good about resisting that, maintaining its depth, maintaining its compaction, and maintaining its R value over time. And so this is the study I was talking about with the formaldehyde thing. I was talking to the owner of Havelock last year sometime, and he brought up, wool filters your air. And I went, okay, sure, buddy, whatever, all right. And it turns out there is a whole paper on it, right? And this paper is called Improving Indoor Air Quality by Using Sheep Wool Thermal Insulation. And this is something that you should look up, right? Even if you're not planning on using it now, this is so cool. The big takeaways are that wool will absorb VOCs, and specifically they tested for formaldehyde, right? Which is a very common household contaminant. It's a health concern for a lot of people. I talk to a lot of people who, will ask me if there's formaldehyde and stuff. The wool just sort of eats it. And in their test, it absorbed almost 70% of what they introduced to their sample in the testing. So it can improve your air quality, which is it's mind-blowing to me. Not that you're funneling a bunch of air through your walls, but it's really cool. And as it absorbs formaldehyde, it also becomes antimicrobial, which, then if you're having to deal with it later when you're tearing down the house in 100 years, then maybe it's less cool for you. But if you're living in the house, well, the wool is eating formaldehyde and just being in your walls. It's nice to have it be a little antimicrobial. So very cool. Read the paper if you're a nerd like me. It's worth some time. And finally, so I want to start addressing questions that might be in the chat while we also look at an example project. So I worked pretty closely with the owner of this project. He actually was kind enough to sit down and do like an interview with us about how life has been with all this stuff. He used cork for his exterior insulation. He used blown-in Havelock wool for his cavity and attic insulation. He also put in a Zender system for his ventilation. He air sealed it. And so the owner was a builder his entire career, and he did more conventional code construction stuff. And when he retired, he really wanted to put a lot of skills and a lot of love into a project. So he built his retirement house by himself for kind of for fun. This house blew a 0.12 before sheetrock. That is the lowest number I've ever heard from a blower door test. He built this by himself. He air sealed it by himself. And so here on the outside, you can see there's some thermocork, and he's got his rain screen over it. This is where a lot of my pictures of the cork have been coming from. And of course, he ventilated it correctly. He has reported nothing but good things with his home so far, which of course, it's new, it's beautiful, it's in a beautiful place, it's up in the islands, it's made with lots of love. I wouldn't expect less, but it is nice to know that there's nothing terrible popping up that was unexpected. So this is the exterior side here, and again, rain screen because we're Pacific Northwest. Um, Basically, it's just a drainage system for your cladding. So with that, I want to take a look at our chat here and see if we have any questions. Wraparound porch. Yeah, you got to follow the sun. I don't see any questions in there, so I will just keep going with this gorgeous house, unless I'm looking at the wrong one. Nope, that's just the chat. Okay.
Hey, Eric, one just came in
Oh,
that
sure.
says, what was the report?
Oh, the report about filtration. Here, I'll scroll back here. This is, so down at the bottom where I say check out the paper, it's called Improving Indoor Air Quality by Using Sheep Wool Thermal Insulation. It's from 2021. I forget who the publisher was. It is published on NIH's website. Um, and yeah, it's definitely worth checking out. They also talk a little bit about its thermal properties and its moisture management properties. So it's more than just the VOC absorption, but um, that's really the one that always blows me away. Oh, here, I love this picture. So here's the owner's feet as he's blowing insulation into his rafters here. Some more shots of that. So you can see how he's got everything netted. And then in the this picture on the left and the bottom, you can see how he's getting it into these cavities that are kind of tough. He's just got a little hole there. He's blowing it in through that hole. And then on the right, you can see his HRV ducting because he ventilated his airtight home right. I'll stop now. This is just the detail of that rain screen and his cork siding. So this is a good detail for if you're putting it together and you're not using like the facade method where that is your cladding as well. I would recommend a rain screen for everybody. Maybe down in California, you know a better way for your climate. I'm up here and I'm paranoid about moisture, so I say rain screens for everything all the time. And then I think he's got some blue skin back there for his WRB. That's back behind his insulation. And we'll just finish up with some more shots of the wool. And I'll give you a couple of minutes. If anybody has any questions, comments, anything that maybe I missed or you'd like to know more about, give you a second here to get that in. I think we're a little ahead of time. Yeah, a little ahead of time. We've got a question about a wood wall assembly in California behind a shower water barrier and tile assembly. Use of dense shield water barrier on the interior of the shower. GC removed existing cement board and used dense shield to seal up the existing 25-year-old fiberglass. No air sealing. Getting mold. Okay. From the interior of the shower. Here's from the exterior side. So I think the question is best shower wall assembly, and that is not something that I am a great person to ask. unfortunately. That is not a detail that I have looked into a ton. Um, so I do not have a great answer for on that one. I'm sorry. Um, I can say that probably the mold issues were like failed caulking or something like that. Or, maybe it was just, like you say, that convective loop from the shower getting hot, warming up your wall cavity. Oh, okay. Yeah. Then Tyson says air tightness would be super important and you'd have some convection loops. Yeah, generally, if you're getting condensate inside your insulation, it's going to be air movement through, and especially if you have a big temperature gradient. So awesome. Well, it looks like that's it for questions. I'll do a little outro here and then I'll hang out for a second if you did not get yours in yet. But with all that done, thank you guys so much for being here. You can reach me at Small Planet Supplies Tumwater office. My email is just my first name, Eric, ERIC, spelled with a C because that's the right way to do it, at smallplanetsupply.com. You can also call the office Monday to Friday, 8 to 4:30, and they'll just send you right to me. Or you can talk to Rick. There's two of us here. If you want to have a more in-depth conversation about this or any of the stuff we provide, I do a lot of our service and our tech support. So I'm out of the office every once in a while. I do commissionings and things. But if I miss you, I'll get back to you when I return. So like I said, I'll hang out for a second and answer questions, but thank you again. I hope you guys have a great Friday and a great weekend, and I'll hand back to Itzel.
Oops, sorry, on mute. Thank you, Eric. Would you mind switching the slide? The next slide. There we go. Okay, so just very quickly, if any of you have any questions regarding AIA learning units, we have them. Feel free to email me. I'll drop my email in the chat, and then slides in the recording will be coming to you sometime in the next couple of days. And then just some upcoming courses. I do have a poll for you all that I'm going to launch about just any suggestions you all might have for future trainings. Any feedback is really great to have. It really informs the way we design our program and the type of trainings we bring to them. So if you have any time to fill that out, that would be very helpful. And I think that's it for me. I'll hang out too, but if there's any questions for Eric, feel free to put them in the chat or unmute yourself. But thank you all.
Guys, that was great.
Awesome, thank you. And then I just I dropped my email in there as well. If you want to shoot me a message or ask any questions or down the road. We're usually pretty handy for general building science stuff. We have kind of a funny organization that's here to facilitate building science by being a business. So it's a weird thing, but give us a call.
Awesome. Well, I don't see any questions. I guess it's time to let you all go.
All right.
Have a
Well,
great rest of your Friday. Bye.